A very good evening to the folks in India and a very good morning to the folks in the States. Well, welcome to the live training demo of Big Data Hadoop Developer by Srinivas Mallampati. Now, firstly, let me go ahead and give you guys a quick heads up as to what TechyBees is and what we do. Now, TechyBees is a premier IT training and consulting firm headquartered in Nashua, New Hampshire, and we also have an offshore office in Bangalore, India. Now, we have been in this industry for quite some time, and we have successfully trained more than I do not wish to give a count, but yeah, well, we have trained a number of people across various sectors, including including the IT, the insurance, the banking, and many more. Now, let me go ahead and give you a quick introduction about the trainer. Now, the trainer's name is Srinivas Mallampati, who comes with a good 18 years of total experience in IT as a consultant, trainer, mentor, with over 19 years of experience in assisting staffing organizations in mentoring their candidates in J2EE, which is Java, Spring, Web Services, Hadoop, Yarn, Spark, Storm, and other ecosystem components. Now, with about 6 years of experience in Hadoop and its ecosystem, ecosystem like Pig, Hive, Scoop, HBase, Apache Spark, and Scala, and is also actively involved in training and mentoring organizations in their Hadoop usage analysis and implementation. Now, Srinivas has trained participants from companies like JP Morgan Chase, Microsoft, Wells Fargo, Fidelity, Amdocs, Bank of America, Vodafone, and he's also done online trainings for companies like Zarentech, Nishitech, TechyBees now. He's done training for Idureka. He's done training for Simply Learn as well. Now, Srinivas has exposure in different phases of software development, lifecycle, including business requirements, system analysis, documentation, designing and development, CR management, unit testing, and integration testing as well. Now, he's always got a participant satisfaction in terms of training. He's got a consistent participant satisfaction of more than 90% in all his training batches. Now, Srinivas specializes in Hadoop, Yarn, Spark, Storm, Data Science, Hive, Pig, Scoop, Java, Spring MVC, Savion, BPM, and SD Insight. Now, that's a quick introduction about the trainer. Now, we would now go ahead and start the training session. Srinivas, I would request you to please take over. Thank you.
Thank you, Sunil, for giving a good introduction about me. Thank you, friends, for joining with us this evening to see something on big data, Hadoop. Every one of you has got your own expectations in terms of big data or Hadoop. Before I go into the actual technical discussion, I would like to brief what we are going to do in the today's, you call it as a demo or an introductory session or an overview on big data. So I planned this way for this evening to make you to clearly understand what is big data, and how big data is well connected to Hadoop. And we talk about Hadoop ecosystem, and we end up with Q&A. It is sure that before you plan to take this demonstration, you might have done enough homework in understanding what is big data and how big data is connected to Hadoop, what other components you have as part of Hadoop ecosystem. More interesting, this demonstration, I want to make it a bit different by showing you something a very practical approach towards what we are about to do in the coming days as part of this big data space, which we haven't done before, which we would like to do this time to make the participants to clearly understand what exactly you are going to do as a Hadooper in the coming days when you go to the workplace. Before we talk anything about the technical aspects, let me start with what is big data. This is one good thing that you always can learn from history. When you fail to understand something on its own, it is always good that you divide and try to conquer it. Divide and rule is the best way that you can understand certain times. You fail to understand what is big data on its own. It's good that you understand what is data first and try to add big to that. You will be able to understand what is big data. Friends, you have any technical difficulty in listening to us? I hope all of you are able to listen to us. You have any technical difficulty, my people will assist you in getting your Sunil. Sunil, you are there?
Yes, Srinivas, I am.
Yeah, I think few of the participants has some.
Yeah, we are. We will take care, Srinivas. We will assist the candidates.
Wonderful.
No worries.
Wonderful.
Yeah, thank you.
This is just to make you to understand, as part of big data and data science, various roles and their pay packages, more or less, maybe slightly this way, that way. And even you see the ratios of, or the propositions of how the various roles in the big data space, big data jobs, statistics jobs, Hadoop jobs, data science jobs, and analytics jobs. And this slide gives you a wonderful understanding about where we fit in, how we need to start our travel as part of the big data space to reach to the extent of data scientist. Though it is not mandatory that everyone need to start as a data engineer, but it is always good that you start your career as a data engineer into the big data space. Eventually, you move towards data analysis, and with your domain expertise and your statistical skills and your ability to design, develop and implement algorithms, you rise to the extent of data scientist. A quick introduction to give you the briefing to make yourself ease to get into the big data space. I thought of showing you all this stuff. As been mentioned by me, as part of the today's discussion, I would like to clearly make you to understand what is big data, how Hadoop facilitates the processing of big data, Hadoop and its ecosystem, probably an interesting thing which we planned for this session, a true technical aspects of what we do as part of your Hadoop ecosystem. As been mentioned by me rightly, you fail to understand something on its own, a good practice. You try to understand what is data first, and then you try to add big to that. You'll be able to understand what is big data. It's my small experiment to give you the understanding of big data slightly in a different style. Bear with me for a few minutes to get the clear understanding of what exactly big data is. This slide gives you a clear understanding. You have data at the lowest. When data is synthesized in the given context or processed in the given context, you get information. When information is further synthesized, it gives you the knowledge. When knowledge is further synthesized, gives you the wisdom. With wisdom, we make the decisions, right or wrong. And this is what we popularly call it to be DIKW model. Data, information, knowledge, wisdom. With wisdom only we make the decisions. Based on the decisions only, the future of the organization depends. The future of the organization depends. So data, you like it or not, directly or indirectly, gives the path to the organizations. So the future of the organization directly or indirectly depends on data. This slide definitely might have given you the understanding data is essential. Data is crucial, very important. Look at this one, you understand. Data at the very lowest. Keep going in this pyramid. You gain wisdom. With that wisdom only, you are able to make the right decisions to put your organization in the right track. What we call it as DIKW model. Data, information, knowledge, and wisdom. If there is no data, there is no information, no knowledge, no knowledge, no wisdom. Without wisdom, we will not be able to make any decision. So it is very clear that data is the foundation. I don't know whether you agree with me this or not. In the contemporary world, the valuation of the companies, earlier, the valuation of the companies used to be like this, depending on the manpower, the skilled manpower you have, depending on the assets, physical or even logical. We used to define the valuation of the organization. Those days are gone. Now, the valuation of the company is primarily depending on the data part. That is how companies like Facebook and all, they're worth billions of dollars, not because of their infrastructure, not because of the manpower what they have or the skilled resources they have. It is all because of the data they are sitting on. Data is going to be very crucial. That is the reason why we say we are living in the world surrounded with data. We are living in the data world. We are living in the data world. You see surrounding, everywhere you have data. Everywhere you have data. Who is able to capture, process, analyze, and get the meaningful insights of this data are going to prosper as part of this contemporary world. So data is going to be very, very crucial. Of course, it is crucial in the past, it is more crucial in the current day world, and much more crucial in the coming days. To make you to understand in its simple terms, data is said to be raw, unorganized facts that is expected to be processed. The same data, when it is processed, you get information. I tried to give a simple example to make you to understand what is data. Each student's test score is one piece of data. May not be much meaningful either to the class teacher or to the school principal. But the class average score or the school average score is going to be more meaningful. It's going to be more meaningful. That's what I would like to share with you, what we mean by data and how that is connected to information. Before I move on to my discussion, the next discussion on big data, I would like to hear from any of your end. Please unmute yourself, friends, and give your opinion about what we mean by big data. You definitely might have done some homework before coming to this demo. I would like to hear from one or two from your end to get the feel what is big data.
Collection of data.
Collection of data. I appreciate. I'm not going to discriminate. I'm not going to comment on any of your opinions because we are in the process of understanding what is big data. But to get the feel of where exactly you are and what I need to do in the next 1 hour of time, I would like to hear from your end. Anyone, friends? Big data?
Huge amount of data.
Huge amount of data.
How the data is
large
stored
amount of
and how
data.
processing happens.
Large amount
Yeah,
of
it is like handling and retrieval of the data.
I appreciate.
Data is stored.
Let me also
The unstructured data.
unstructured data. That's cool. That's good to hear. That's good to hear. That is the reason why now when I ask you to talk something about big data, every one of you came out with your own opinions. Please mute
It
yourself.
is collection of structure and unstructured semi-structure.
That's good to hear.
It is collection of structure, unstructured and semi.
How to store
Structured,
the data.
unstructured, and semi-structured data. I appreciate.
Semi-structure
I appreciate.
collection of.
So when the question being asked about big data, every one of you came out with your own perspective. Now, it is definitely tough for the followers to understand. If everyone starts coming out with their own opinions about big data, then we are confused. Every of your statement is appropriate. Every of your statement is appropriate. The same I ask you, if I ask you to talk something about a good citizen, everyone will start coming out with your own opinions. A good citizen is one who pays taxes properly, who obeys laws, who respects everyone, who is not harmful to the society. Everyone starts coming out with their own opinions towards what we mean by good citizen. That is the reason why either government or court of law is going to define something about good citizen. Same is the situation even to the industry. When I use a term called big data, everyone starts coming out with their own opinions. Then it is tough for us to standardize it. That is the reason why industry has standardized what is big data. Big data is anything. Big data is anything which has got three essential characteristics. Is anything which has got three essential characteristics. What are those characteristics? Volume, variety, and velocity are the three essential characteristics with which we define something called big data. Big data is anything which has got three essential characteristics: volume, variety, and velocity are the three essential characteristics with which we define something called big data. Let me take the privilege of explaining you. Compared to the books what you have in your shelf, these are more in volume. Compared to the books what you have in your shelf, these are more in volume. What do you understand from that? Volume is a relative term, not absolute. It is not an absolute term. It is always relative. Compared to the data what you have on your laptop, someone else may be having more. Compared to that, an organization has more. Compared to that, a corporation has got more data. So volume is something which is always a relative term. Is always a relative term. So you may ask me one thing, what is the impact of volume then? Look at this slide, you'll be able to understand. The amount of data that is coming into your box every day is a classical thing that you can understand, friends. You yourself do a basic analysis. From Jan 1, 2016 till 31st December 2016, the amount of data that you have gathered as an individual, estimate, a rough estimate of the amount of data that you have gathered from different sources, downloading some documents, collecting some audio files, taking the photographs from your mobile phone, from different sources, whatever the data that you have gathered, you just estimate that probably 20 GB, 30 GB data you might have collected. And you also keep an eye from Jan 1, 2017, and you move ahead, definite by mid of 2017, you might have surpassed the amount of data you have collected whole last year. Various reasons, friends. Maybe because of the reason that your needs are getting increased day by day, the devices you are using are becoming more, or the data storage is becoming cheap. Whatever the reason, data is coming into your boxes in a predominant fashion, in an exponential fashion. So you may ask me one thing, what is the impact of this then? The amount of data that is coming into your box day by day is growing up. That is the reason, that is what I'm showing you with the upward graph here. The upward graph is clearly giving you the insight. Data coming into your box is growing up. But the ability to process that data is coming down day by day. As a result, there is a blind zone that is getting formed between these two. I mean, the data which is left unprocessed. Till you process the data, you should imagine that there is a gold inside it. Till you process the data, you should feel that there is gold inside it. You come to know whether that is useful or useless only when you process the data. So, your volume is throwing me a challenge. Your volume is throwing me a challenge. How and where we store huge volume of data. Look at this one very closely, friends. How and where we store huge volume of data. How we store and where we store. Until and unless we store, we will not be able to talk anything. We can talk about the data, maybe processing or anything, only when you successfully store it. So volume is throwing you a challenge, how you store huge volume of data, where you store huge volume of data. Hope you have understood, friends. This is how your data is usually been calculated. 8 bits put together one byte, 1024 bytes put together 1 KB, 1024 KB put together 1 MB, and 1024 MB a GB. Such 124s you keep adding. You have terabytes, petabytes, exabytes, zettabytes. Beyond zettabyte, you have something called yottabyte. So we are traveling towards zettabytes. We are traveling towards zettabytes. Soon we cross zettabytes, and 1024 zettabytes, when you cross, you are entering yottabyte. That's how the data is exponentially growing year by year. So the impact of this one is where you store this one and how you store this one. And this is also throwing you one challenge, that how you process the data. Say today you got 2 GB of data into your organization, but your current infrastructure is supporting to process only 1.8 GB data. What about the remaining 0.2 GB data that is not processed? Today we have 0.2 GB data left, tomorrow another 0.2 GB data left. Over a period of time, the blind zone increases and we are losing the meaningful insights from the data part. That's all about the first characteristic called volume. And the second one, variety. I'm trying my best to show you, to make you to understand. Alone in the text format, we have TXT, DOC, XLS, PPT, all. In the image format, you see GIF, JPEG, PNG, BMP, whatnot. And in your MPG, AVI, WMV, alone in the same category, we have different. There are hundreds, thousands of data formats. And this is throwing me another challenge. When you have varieties of data, You have hundreds, thousands of varieties of data available in the real world. How to store wide varieties of data? Because your traditional RDBMS, which is a schema first, you are going to define the schema. Only that type of data is being allowed to be stored there. If you try to store the data other than what is being defined, it will not allow you. But when it comes to big data, you really don't know from which different source you get the data and how you store these wide varieties of data. So your variety is throwing one more challenge. What is that? How you store these wide varieties of data. Both your volume and variety are throwing me a challenge related to storage. Hope you have understood, friends. Big data is anything which has three essential characteristics: volume, variety, and velocity. Of course, we technically call this as 3 V's, but these V's are getting extended like veracity, viscosity, value. These V's are getting extended from time to time. These are extension to your core, but the core is the same. Big data is anything which has got three essential characteristics: volume, variety, and velocity. In addition to these three V's, we have other V's coming up. We will be talking more in detail about those probably at the later stage. But the first two V's are throwing a challenge to me related to storage. What is that? Where you store huge volume of data, how you store wide varieties of data. We don't know the answer, but it is just throwing me a challenge. Coming to your third factor, that is called velocity, you look at that one. I don't know what you understand from this. I don't know what you understand from this slide, but if you look at this slide closely, different weather sensors are emitting the data and being collected by your weather server. You call it as your box, your weather server. You got all the data from all these sensors from different parts of the country or global. Imagine if it takes 24 hours time for you to process the data before you emit the results to your customers. By the time you are about to share the results, the disaster has already happened. This is what the classical example that always I give, which is very easy for you to understand. You came home, you switched on your television, someone on the screen reading the news saying, yesterday there was a heavy rain in city. Does that make any sense? It is definitely, maybe you are listening to that, but it doesn't make much sense to you because you already enjoyed it. Yesterday there was heavy rain in the city. One need not tell you because you have already experienced that. It doesn't make much sense to listen to someone saying yesterday there was heavy rain in the city, but it makes more sense. Tomorrow between 9 and 10 in the morning, there may be possibility of having heavy rain in these parts of city. In these parts of city, it makes more sense, friends. Tomorrow between 9 and 10, there is a possibility of heavy rain in these parts of city. If you have a plan to go to those parts of city, you are well prepared. You understand from this slide very clearly. The rate at which the data is coming into your box, at the same rate, you must be able to process that. Then only you are able to give the meaningful information to your end users. The rate at which the data is coming into your box, at the same rate, you should be able to process it. If you are not able to process the data coming at a faster rate, then you are not able to give the meaningful information to your end users. So my third V is throwing a challenge to me, how quickly we process the data. How quickly we process the data. So you look at this one very closely, friends. You really appreciate. We are talking something about big data, and we have identified your volume, your variety, and your velocity. Your volume and variety are related to your storage, and your velocity is related to your processing. Now I ask you, friends, what you mean by big data? Is big data a technology? Or big data is a platform? Or big data is a framework? Or big data is a language? After listening to my half-an-hour discussion on big data, I would like to ask you, friends, what you mean by big data now?
Big data is just a term given to the data. That's it. It's nothing more than just a word.
Appreciate. Can I say like this? Big data is a problem statement. Can I say this one, friends?
Maybe.
Because it is throwing a problem to me, how and where we store huge volume and wide varieties of data, how we quickly process the data. That is all about big data. So definite, friends, we can say big data is just a problem statement. It is not a technology, it is not a platform, it is not a framework, it is not a language, it is just a problem statement. To this problem statement called big data, you have an open source solution called Hadoop. Big data is throwing me and processing. Hadoop has got HDFS and MapReduce. Your storage problem is well addressed using your HDFS, and your processing problem is well addressed using your MapReduce. So big data is just a problem statement. To this problem statement, Hadoop is an open source solution in the form of HDFS and MapReduce. Whenever you hear the term called Hadoop, it implicitly means HDFS and MapReduce. It implicitly means, wherever you read Hadoop, the moment I hear the term called Hadoop, it implicitly means core. How I store my huge volume of data, how I store my wide varieties of data, the solution is HDFS, called as Hadoop Distributed File System. It is your regular file system, but a distributed file system specific to Hadoop, which is linearly scalable. Your HDFS is linearly scalable. Linearly scalable, I mean, today your need is to store 20 TB, but down the line, your 20 TB need becomes 25 TB, becomes 30 TB. So you just need to add. Today you have a cluster of 10 nodes and your need increases. I just add a few more nodes to the cluster. That is what I mean by linear scalable. I need not thrash my existing environment. But if it is a case of your traditional enterprise data warehouses, they have got the limitation in terms of storing the data. Beyond some limit, if you try to store the data, it fails or the performance starts degrading. But whereas your Hadoop distributed file system is such a wonderful file system, with Yahoo as of now, you have a 13,000 odd node live cluster running. Still the number is growing. 13,000 node live cluster running with Yahoo. The Hadoop cluster. That is what I mean by linear scalability. Your need increases, you just need to add few more nodes to improve your storage capacity. Not just linear scalable, your Hadoop distributed file system is fault tolerant. For any reason, out of these 13,000 nodes, one node is down because of the hardware failure or network disconnection, whatever the reason. Still, your data is made available. That is what I mean by fault tolerant. Your Hadoop distributed file system is not just your traditional distributed file system. It is a linear scalable fault tolerant file system. That's what the beauty part of your HDFS. So your HDFS never puts a constraint that I allow you to store only 20 TB of data, 30 TB of data, or only these type of formats. Let your data be anything. If it is data, your HDFS says, yes, come and store with me. That's what the beauty part of your HDFS. So your storage problem, which is posed by your big data, your huge volume of data can be comfortably stored using HDFS. Your wide varieties of data can be comfortably stored with HDFS because HDFS is not a schema first kind of storage like your traditional RDBMS, where you need to define the schema. Fitting to that only you can store the data. Anything other than that, what you are defined, you are not able to store it there. But your HDFS is not like that. It is just the storage in that you can store semi-structured data, unstructured data, of course structured data. And your MapReduce programming model is a simple programming model which is backed by massive parallel processing. Massive parallel processing, I mean you have your nodes with the data blocks, and within this node these three blocks are getting processed parallelly, not one after the other. All these three blocks are getting processed parallelly, same point of time. On the other node, even these blocks are getting processed. Within the node there is parallelism. Across the nodes there is parallelism, which we technically call it as massive parallel processing, which is a backbone for your MapReduce. Sorry friends, if you are not able to get the right concept of massive parallel processing, because this being a very short duration, I'm not able to talk much about MapReduce. But MapReduce is a simple programming model backed by massive parallelism, which makes your data processing to happen at a lightning speed. That is what I'm trying to depict here. The rate at which the data is coming into your box, at the same rate I was able to process. It is almost like on the fly. The data is getting processed. That makes my Hadoop to be the best choice for all my storage and processing needs. I hope friends, with this you are able to clearly understand what is big data and what is Hadoop and how your big data and Hadoop are connected to each other. The moment you hear the term called Hadoop, I implicitly mean by core, which is both your HDFS and MapReduce. You go through any document or any demonstration in the internet, friends. I'm not boosting myself. Believe me, you will not find anywhere the description what we have undergone now, because this can be defined only by the people who has got bigger insights of what exactly big data is. So big data is not a technology. It is not a platform. It is not a language. It is not a framework. It is just a problem statement. To this problem statement, the open source solution is Hadoop. As of today, we have Hadoop, the only open source solution, but is being adopted by organizations and tuning to their specific needs. Hadoop is an open source from Apache, and people are adopting this one and trying to customize to work in their respective contexts. Let it be from Cloudera, from Hortonworks, from IBM. Let you get the Hadoop from, your big data solutions from any of these corporations. All are bundled with the same Hadoop from Apache. They're just integrating all the components of your Hadoop, which are given by Apache and being bundled by the people. Say, for example, you take Cloudera. What they have done is all the Hadoop components are bundled into a bundle by name CDH. Cloudera distribution for Hadoop, that is what CDH. Hortonworks says the same thing as HDP, Hortonworks Data Platform. Same from IBM, that is they call it as Big Insights, IBM Big Insights. Let it be CDH or HDP or Big Insights, anything, all has got the same Hadoop and its components. So I would like to share with you friends now what we have as part of your Hadoop ecosystem. You see this one closely, you'll be able to understand how exactly your, have a look at this slide, you will be able to understand. Very lowest you have data storage, where you have HDFS. Similar to HDFS from Amazon called S3, Simple Storage Service. HBase, the structured database for your Hadoop. NFS with Mapr, Cloud Store. Let you take any of these storage, more or less they are the same techniques. Only the flavor is different, but at the grassroots level, all has got the same philosophy. Distributed file systems with fault tolerance and linear scalability. On the top of your data storage, you have your data processing, which is your MapReduce framework. And on the top of your data processing, you have data access, Hive, Pig, Avro, Mahout, and Scoop. All comes under data access. The beauty part here is you run a Hive query, it will get translated as a MapReduce job and run against the data present on HDFS. We talk about those things practically end of the session. Bear with me, friends. Our ending is going to be wonderful. You'll be definitely thrilled to see how you process the data at your cluster level. Bear with me to give you the right introduction towards big data so that you will be going to the extent of how this data can be processed at your cluster level. On the top of data access, we have data management. Uzi, Chukwa, all these as part of your data management. On the top, you have data analytics. You look at this one closely, you really appreciate, you understand that at the very lowest level, you have your data storage. What is that? Data storage. Until and unless you are able to store, you cannot do anything. Data needs to be first stored. Then you can process that. Then you can access that. Then you can manage it. And on the top, you have analytics. Data storage, data processing, data access, data management, and data analytics. All surrounding your data part. Storage to processing to access to management to analytics. That is what? This is what we technically call it to be Hadoop ecosystem. The moment I use a term called Hadoop, I implicitly mean by core, where you have my HDFS and my MapReduce. So this is what we call it to be your Hadoop core. On the top of that core, we have access and management, which we call it as ecosystem. The ecosystem that is built on the top of your on the top of your Hadoop core. You have all these components as part of your, which you are going to see here. So with this, you are able to understand clearly what we are going to do as part of our courseware. Definite, we are going to learn as part of our program, we are going to learn about HDFS, no doubt. Why we need to learn about HDFS? Until and unless we store the data, we will not be able to do anything. We definitely talk about MapReduce. As part of Access, we talk about Hive, we talk about Pig, we talk about Flume, all these we talk. And coming to the management, we talk about Uzi, Zookeeper, all these things we talk in terms of the management. So this is going to be a course which gives you the understanding of how we ingest the data. So these are the different sources. That is where I'm trying to draw with the different diagram. These are the different sources. From these sources, we are going to get the data into your HDFS with the help of the tools or the components like Flume or Kafka or Scoop. Scoop is a tool with which you are able to get the data. This is what we call it to be import, and you get the data into your HDFS using any or one of these tools. Once the data comes into your HDFS, probably we are going to massage the data. We are going to massage the data usually using your MapReduce. That massage data is again put inside your HDFS. This is what the original data that is being bought into your HDFS, and this is being massaged using your MapReduce where you got this one. And this massage data either can be transformed using Pig. It is not necessary, friends, that every time you need to transform. Only when it is required, you transform this data using Pig, you get the output, which again you store it over here. And on this data, you are going to project the structure. You are going to project the structure using your Hive, and using this Hive, you start querying using your HQL called as Hive Query Language, or this data can be exported to your RDBMS. On this RDBMS, you have your BI infrastructure already in place. Anything can happen. There is no thumb rule that you must do like this. But one thing you need to understand here, friends, very clearly, you have the mechanism to get the data into HDFS using Flume, Kafka, Scoop kind of components. Once you get the data into HDFS, you start processing that one, which we technically call it as data massaging, initially with your MapReduce, and data transformation usually done using Pig. I said usually using Pig. And that transformed data is structured using your Hive, and on the Hive you can start querying it using your HQL. And that's how you're going to do your things, friends. So let me give you the details once again. Hope you have understood clearly with this entire demonstration what is big data and what is Hadoop, and as part of Hadoop, what components we have or ecosystem, and as part of this one, what your HDFS is doing, what your MapReduce is doing, what your Pig is doing, your Hive is doing, your Scoop is doing. all these components, they play their individual role in making up your things. Your HDFS is going to make you to store the data, and this stored data is being processed using your MapReduced, what we call it to be data massaging, and this massage data is being transformed using your pig, and the transformed data is being structured using your hive, and after that using Scoop I may be exporting the data to my RDBMS. This is what my RDBMS, where I have my tables, my data into store is coming from some source, and from that data I am extracting the required data. From the extracted data I am using my pig to transform, and the transform data is being loaded into my hive warehouse. This is what we say your ETL. So your Hadoop is going to form, I don't know what exactly your vision towards enterprise data warehouse, friends. EDW, you have different data sources from which you are going to extract. After you extract the data from different sources, you are going to transform, probably using your Informatica kind of thing. You transform the data, and the transform data is loaded into your loaded target database, and this target DB is equipped with your BI tools. So what we do now is, this Hadoop ecosystem is going to form a layer. Now, instead of you getting it over there, you also can get your data into your HDFS. You start getting your data into your HDFS, and you extract whatever you require using your MapReduce, and you transform it using your pig, and you either can load into your hive, or that data you can load into your existing enterprise data warehouse infrastructure. From there your BI runs as is, or on the top of this one I set up my own BI. This is your big data based BI, and where your analysts are going to sit and analyze the data, start generating the reports, whatever it is. So your existing enterprise data warehouse will be as is, because I want to address to the questions usually what people are going to raise. Is your existing one second, existing enterprise data warehouse, is it going to be replaced with your big data? No, never. My existing enterprise data warehouse is never going to be replaced with Hadoop. Instead, it is going to be an addition. It is going to be an addition to your existing enterprise data warehouse. Your existing enterprise data warehouse is going to be leveraged with your new ETL. What is that new ETL? Your Hadoop based ETL. Instead of you extracting your data from different sources, transform and load it into your target database to perform your BI activities, all your existing data sources now can be leveraged to your HDFS, where you perform your extraction, transformation, and loading into your Hive warehouse. And on the top, you can have your regular BI as is, or the new BI being built. To make you to understand this one practically, friends, I would like to take a brief thing towards, let me show you. This is your Hadoop environment on which you start practicing in the coming days. This is a virtual environment which is running on my box. where I have my imagine this is what the data I have, friends. You can count the number of records also here. You may ask me one thing, Srinivas, all this time you have talked about big data with huge volume, wide varieties, and lightning speed and all. Now you are showing a small data set to us where things are getting correlated. Don't mistake me, friends. The core intention of taking small data sets during your learning is to make you to understand clearly if this is my input when being given to my job, this is the output I got, whether my job is giving me the expected outcome or not, you will have the conformity. If you are working with a huge data set of 20 TB, you process that one, you don't know what is the input, you don't know what is the output. You will not be able to calibrate. That is the reason why usually during your learning process, we are going to take small data sets to make you to clearly understand what is your input and
Hello.
hello. Are you able to see my screen, friends? Sunil, Arvind, you have any problem in seeing the screen?
No, Srinivas, there's no problem.
Yeah, Sunil.
You're fine.
Are you able to see the screen properly?
Yes, I am. Yes, I am.
That's wonderful.
Yes.
Yeah, thank you, friends. So you look at this one very closely, you understand this is what the data set I have, where I have few records here. Imagine that this data set I'm going to copy into my HDFS now. Hadoop FS hyphen copy from local, because this data set exists on my local file system, which I need to copy it onto my distributed file system. And I do that sandbox slash what is the file I wish to copy is employee data.txt, which I want to copy it into my, let me narrate this one, friends, very clearly to make you to understand. We have an employee data set here. See, of course, this is a file, but when it comes to the Hadoop terminology, we call it as a data set. Don't get misleaded. Sometimes I call it as a file, sometimes I call it as a data set, depending on the context. Inside this data set, I have data where each line corresponds to one record, and all these are the employee records. Imagine that these employee records are coming out from different sources, either as a log or whatever it is, and that I have collected in the form of a file here. Now, which I am, see, if I am using Flume is going to directly ingest that into my HDFS. But I am now copying the data from my HDFS, from my local file system onto my HDFS. If you look at this data set very closely, you understand, look at this data set. Each is a record pertaining to the details of one employee, where the first token is ID, then name, then location, then your contact number. Each record has got 4 fields, each field is separated with piped operator. But if you look at this one closely, you understand that there are records where ID is not present, name is not present, location is not present. We technically call them as malformed records. We technically call that as malformed records. So this data, when it is being stored into my HDFS, have a look at this one, friends. This is what my file system, Hadoop distributed file system, which I am accessing using my Hue. I go to the file system. Like how your Linux has got root, even when it comes to your Hadoop distributed file system, you have the root here. At root, I have something called TMP. Under TMP, I have something called sandbox. Under sandbox, I have a file by name employee data.txt, which I just copied. What I have shown you on my local file system, I copied to my distributed file system. Now, this file, which is copied onto my distributed file system, I would like to massage that. Now imagine this process, your HDFS, data ingestion has been done. You are able to ingest the data into HDFS. You are able to ingest the data into HDFS. That ingested data now needs to be massaged. What do you mean by massage? All malformed records, I want to remove. Of course, friends, here you have a limited number of records. I told you very clearly why we have taken limited number of records, so that we can have a direct comparison. What is my actual data? What is my outcome from after processing the data? Now the same thing you imagine, friends, this 20 records what we have now, you imagine 20 billion records are there in your actual data set. Even when you come to your actual activity, you'll be having things like this. This is what your dev cluster. On dev cluster, you always will be keeping sample data only. You will not be keeping the original data sets. The sample of the original data sets is being kept on your dev cluster. And from dev to your testing, usually dev and the test cluster both are going to be same. Once you, as a developer, you develop a MapReduce job, you test that MapReduce job using the data present on the dev cluster, everything is fine. Probably the same MapReduce job, you run it on your production cluster. That is what usually you are going to do. That is what usually you are going to do. You are not going to run your MapReduce job directly on the production cluster. You develop a MapReduce job as a developer, and that you try to run against your sample data, everything working fine. Then you are going to submit the same job to your production cluster. So what we are trying to do now is have a look at this one, friends. This is what the data massager that is developed by me, where if my record, if my ID length is less than or equivalent to 2, I am considering that to be a bad record. Otherwise, it is an appropriate record, because if there is no ID also, then I cannot consider him to be employee. So this is what the logic I am applying, and you need not follow the same thing. Depending on the context, depending on the data set that you are going to process, you can apply your business logic as part of your map function inside your mapper class. So when I run a MapReduce job against this data set, have a look at this one, friends. Hadoop ZAR, and I'm going to mrjobs.zar, and this EMP. I believe the job name is EMP Massager is a job name, Massager, and I want the /tmp/sandbox/employee data.txt is the input. I want the output to be sandbox emp data underscore out. If everything is fine, I submitted my job. Because my MapReduce job is present inside my ZAR file, don't worry about the deeper details, friends. I'm running my MapReduce job to process my data. When the job is been submitted, you can see that here in the manage job section, you'll be able to see your job is being submitted just now. That is called employee data massager, which has been submitted, has been accepted. everything is fine, you are able to see your job being executed successfully and able to produce the output. You see that one here, friends. Your map 100%, reduce 0%. So your job is running now, which you can see that practically here, your map 100%, and you see good records are 14 and total number of records 17. The total number of records. Let me take you to the place where the output is being stored. You also see that the job is being successfully executed. You can see that one here very clearly. Your job is being successfully executed. Maps 100%, reduces also 100%. Your map reduce is a two-layered programming model with which you are able to process your data efficiently using simple programming model. You go to your HDFS now. As part of the HDFS at the root level, you see your TMP and your sandbox, EMP data underscore out, and you see this part.tar file. Now see, friends, what the logic I've implemented. You look at the data set also clearly, friends. Here you will be able to understand clearly that I have few records missing with employee ID, which are been taken out here, and I have duplicate records that also been taken out. Compare these two things, friends. You are able to clearly understand on your own. CS101 is twice, but you are able to see only once. Don't worry about the deeper details, friends. As I mentioned before, Cloudera is a bundle which is provided by, that is what? Cloudera is one company which is providing you the bundle with which you can comfortably work with your Hadoop. So don't worry about the deeper details. As part of our program, we are going to see everything very in detail. This is only to make you to understand how your components on Hadoop able to help you in making up your things. I think you remember in the beginning I said you have a data engineer role, you have data analyst and data scientist. Now you as a Hadooper, you are starting your career as a Hadoop engineer or a data engineer. What a data engineer is going to do? The role of the data engineer is to ingest the data into HDFS, massage the data, transform the data if required, and load the data into your warehouse so that you are able to perform the analytics on the top of that. Now you see, this is my actual data set present on HDFS. This is the output produced by your MapReduce job, where I have all the unwanted records eliminated. All the unwanted records are being taken out. Duplicate records taken out, records with missing data taken out, and I also come to know how many records are there total. This is one other thing that you need to understand, friends. How you predict or how you are going to confirm data quality. You are going to access the data quality by getting total number of records, and error records and good records. Thereby, you can come to a conclusion whether this data set can be considered for further analytics or not. As a data engineer, how you are going to decide? You as a data engineer, how you are going to decide that this data set is a good data set? How you are going to decide that? You are going to decide that by analyzing your data set. You are going to decide that one by analyzing your data set. How many good records are there? How many bad records are there? The total number of records. Thereby, you can arrive to a percentage. Or if it is a negligible percentage, then you can, yes, this data set can be considered for further processing. Now, what has been done by me, friends? What has been done by me? I have ingested my data into HDFS. This is what I have done. I have ingested my data into HDFS. This ingested data is massaged using MapReduce. As a result, I got this data. Now, here I am showing only limited records to make you to understand and have a comparative study. This is my actual data and this is my output after processing the data. Now on this process data, what can be done? What can be done is, have a look at this one, friends, very closely. Look at this one, EMP table.hql. I am, if at all, if there is any table exists with EMP, that is going to be dropped. And I am creating a table. What is the table I am creating? ID, which is a string type, name, which is a string type, location, which is a string type, contact number you want, you can keep it as a string or even as an int. Row format delimited, fields terminated by. I was able to look at this one. Accordingly, I am creating my SQL file called as Hive query language file, and I'm loading the data into the table so that I can show you. You go to this one, you go to the Hive, inside this, you go to Hive, you're going to see the database by name. There is a database by name. You can see that here. There is a database by name. What is that? TechyBees is a database. Do you have any? You have a table called EMP, right? I think you are able to see that here. You have a table called EMP. If that table exists, then my table is going to be dropped and a fresh table is been created, and my data from this one is loaded into my EMP table. The beauty part is Hive -f EMP table.hql. Have a look at this one. I have successfully ingested the data into my HDFS. I massage the data using my MapReduce, and on this massage data, I am projecting the structure. When I project the structure, I will get like this. And using this structure, I can start querying, which I'm going to show you once I get my processing done about yes. What has been done? Loading data into the table is done after the table has been successfully created. Now you go here and you select from here, select star from EMP. I say execute. See this one here? I have all the data here. I have all the data here. I also can have, depending on how the data is, you can see the ID. Of course, it is not that meaningful here, but you can get your, based on the location, you are able to see what is that. You are able to make your basic analytics on the top of this one. The same, select star from EMP where location equals to HYD and contact number like 21 percentile. Have a look at this one, friends. You'll be able to understand. Select a star from EMP where location equals to, and what is that? Recognize, sorry, and so have a look at this one. When I am trying to run that query, it is processing that one, and you look at this one very closely. A MapReduce job is running for you in the background, which is processing your data, and trying to let me one way of executing your part is using your Hive editor, using your Hue, that is called Hadoop user experience, which is a user experience from Cloudera. You can go in that mode. And the other way is like using your SQL prompt, like how you have your SQL prompt, same like that here. Show databases. It is going to show you what databases you have here. Use TechyBees. And I can say here, show tables. I'm able to get the tables. Select a star from EMP. I'm able to get the data from that. Same like I'll be able to get even select star from EMP where location equals to HYD. You have a look at this one. What is happening? Launching jobs 1 out of 1. Number of reduced tasks is set to 0 because there is no reduce activity. It is working like a map reduce job in the background. Have a look at this one, friends. Select star from EMP where location equal to is working as a map reduce application. Now I think you are able to understand, friends, very clearly what I mean by this stack. You have the storage at the lowest level, and on the top you have data processing, and on the top you have data access. When you are running a SQL query through your Hive, what is happening? It is getting translated as a MapReduce job and working as a MapReduce job, but superficially it is like your Hive query, which you are going to see here. Select a star from EMP where location equal to HYD got succeeded. It is working as a MapReduce job, which you can see even here. You see this one? Map 0%, reduce 0%, map 100%, reduce 0%, and finally, because there is no reduce activity involved here, you got only the data pertaining to Hyderabad. I hope you are able to understand, friends, what I mean by this stack. So in order to make you to understand this only, I made this kind of a practical attempt to make you to understand as a data engineer, you are going to ingest the data into HDFS in different ways. Maybe using your Flume, you can ingest that, or using your Kafka, you can ingest that, or using your Scoop, you can ingest that, or using your Hadoop HDFS file system commands, you can ingest the data into your HDFS. After the data is been ingested, you need to cure the data, or you need to massage the data. Usually you massage the data using MapReduce, and that massage data either can be transformed if required, not every time, using pig, and on the transformed data you usually project the structure using your Hive, and once the structure is projected, you observe here, friends, suppose if the data is available like this, will you be able to query? You cannot query it. That is the reason why on this data we are projecting the structure so that we will be able to query it something like this. Select star from EMP where location equals to HYD. You are able to get only the data pertaining to that one. I hope you are able to get the things, friends, what we are going to do as part of your Hadoop career. You store the data, you process the data, you access the data using Pig or Hive or Scoop, and you manage the data using your Uzi, because using your Uzi, you are going to define the workflows and you run those workflows and get your things done. Because it is definitely not possible that you developed a MapReduce job, then you developed a Pig script, then you developed a Hive thing. You cannot sit and run this one, wait till this is going to finish, then you run this one, wait till this is going to finish, then you run this one. You will not be doing that. All these three you are going to make as a workflow. That workflow is going to be executed using your Uzi, and that is been achieved using your you have the same thing here, workflows. You have the dashboards where you can define your workflows, And those workflows can be, once you define the workflow, you are able to submit that and achieve the same thing what I'm trying to share here. Suppose if your MapReduce job fails, then the workflow is going to get halted. It's not going to move further. On the successful completion of the MapReduce job, I'll be going to Pig, and on the successful completion of my Pig script, I'll be moving to Hive, and then it is going to end. It starts here and ends here. What we call it to be your workflow, which is achieved using your Uzi. That is what I'm trying to show you here as part of this ecosystem. And finally, on the top of management, you have something called data analytics. This is what we call it to be your Hadoop ecosystem. Your Hadoop ecosystem. Hope you understood, friends, how we started our discussion. We started our discussion with what is big data, and we understood what exactly it is, how this big data is connected to Hadoop, and as part of the Hadoop, what other components we have, all put together we call it as Hadoop ecosystem, and how this Hadoop ecosystem can be practically used as part of your Hadoop career as a data engineer. So by undergoing this course, you are going to become a data engineer, and over a period of time you can be an analyst, and over a period of time you can be a data scientist. But to go to the extent of data scientist, you need to start your career as a data engineer. What we are going to do, we are going to provide you as part of the course, we are going to provide you all the necessary things. I'm not here to convince you, friends, to drag to my program, and I'm not saying this in a different voice. I'm not saying this in a different voice, but believe me, as part of our program, we are going to make you to set up your environment on your box and do all your practicals. And we also want to be with you till you are going to make up your career in your Hadoop. And it is not just a training program, friends, because our real happiness lies in seeing you as a Hadooper rather than just a Hadoop trainee. Our real success lies in, I don't know how many of you are aware of the name called TechyBees. The name TechyBees is being with a different sounding. I think you are aware, bees are the foundation to the planet called Earth. Human beings can come together and mutate. Plants cannot come together and mutate. The only way to get pollinated is through the bees. If bees are not there, over a period of time, may not be in 1 year or 2 years, over a period of time, your planet called Earth will vanish. Same like we consider the people who take our course as technology bees, where they go to different companies and pollinate to make this IT happening everywhere. That's what the strong goal of TechyBees has been clearly mentioned by Sunil in the beginning. We have a strong goal, and our goal is to see all our participants successful at their workplace, not just undergoing the training program through us or paying something to us. We are going to help you out in setting up your environment and share assignments time to time and make you to finish those assignments. And if you are failing to do those assignments, you are being guided with our team, strong support team, where all your assignments can be addressed by you very comfortably. And the only prerequisite to attend this program is you need to attend every session regularly. That's it. If you are able to spend 1.5 hour to 2 hours of your valuable time 3 days in a week for 6 weeks, you are going to become a Hadooper. No second thought on it. I think you might have experienced with the last 1.5 hour discussion what we made. You can definitely access what we are going to do in the coming days. We don't want to boost much about what we do in the coming days and all this stuff, but believe me, it is the right time to shape up your career as part of Hadoop. Various reports, Gartner reports, and all the big corporation reports says the future is data. The future is big data. So at least it is the right time for you to to be a part of this ever-growing industry, to shape up your career as a Hadooper. And for that sake, this is going to be definitely a good stepping stone to make up your skill set on Hadoop. That has been your Cloudera distribution is provided by the company called Cloudera. Your Cloudera distribution is provided by Cloudera. It is a corporation who provides the Cloudera distribution. But as part of the Cloudera distribution, you have the same thing again. And one other important and the essential thing that I would like to bring to your notice, that not only the pseudo cluster what I have shown you now, we also has got a live cluster with which you are able to get the deeper insights what we are going to, how your actual environment is going to be. Tomorrow when you go to the workplace, it should not be different. That is where we have a live cluster, a 6-node cluster, where all being set up on the independent nodes with reasonably good configuration to make you to understand how your real environment is going to be. Your practice environment and your real environment. You can access that one here. You have your Cloudera manager being set up on a separate. You have your master being set up on a separate. You have your data node 1, 2, 3, 4 being set up on individual machines so that you understand how your real environment is going to be. Tomorrow when you go to the workplace, and it is an open secret to everyone that if you claim that you are a fresher, no one is going to consider. You need to definitely claim experience. At least a year or 2 experience you need to claim. When you claim a year or 2 experience, you should know the actual environment, then only you'll be able to work with it. I don't know about other companies who do this training on Hadoop, but we have stick to the commitment and we have the right values that whoever is going to attend the training program needs to get the real feel of the environment so that they should not feel anything different when they go to the workplace. Keeping that thing in the mind, we have vested our effort and investment in creating a wonderful real environment to make you to understand how you are going to work in the real environment in the coming days. So as part of our sessions, you are going to be shown with the real environment how your Hadoop cluster is going to be. So as part of our training program, we are going to see how all these components are going to help you in making up your big data happening. So this is all about what we have planned for today's discussion, friends. Hope most of the questions that you have in your mind are being addressed, and I'm sure that by this time you are definitely clear in terms of what is big data. Let me recap. What is big data and how big data is connected to Hadoop, and what components you have as part of your Hadoop ecosystem, and how these components are being useful practically we have seen. So I need not tell you, we provide you assignments, we provide you this, we provide you that. I don't want to boost or specifically mention that we do 100 things. In one single statement, I can tell you, as a Hadoop trainer, I can ensure you one thing, being a part of our program, I'm sure even you go to a workplace of any level, you will not feel anything different, even if you don't have 1 day of real-time experience. That thing we can confidently tell you all the times. So hope this big introduction towards this big data, Hadoop and the components as part of the ecosystem, and how these components are being practically used. If at all, if you are confused anywhere, don't mistake us, friends, because we have limited time to give you the understanding of certain aspects. Because of that constraint, we are compelled to do a bit fast. But as part of our training program, we are going to do everything leisurely so that you will be able to understand how each component is going to be helpful in contributing its share to make the whole big thing happening in the big data space. So good to see all of you friends. Now it is your turn. You have any questions? Please feel free to ask so that we'll be able to address your questions.
Hi, Srinivas. This is Loknath here.
Yeah, Loknath, yeah.
Yeah, as I try to understand these concepts, I can see that DT, like this is as same as a data warehouse concept. So is it we have any front end in this big data?
You mean to say when the front end in the sense like the accessing part you're saying?
No, any data capture points or any front end applications is there in this? Or only like capturing the data and projecting that into reports or something like this only? And that.
I'm not sure whether I've understood your question properly or not, but if you see, you mean to say the front end in terms of giving the access to the data, what is being part of your HDFS, that is what you're asking?
Entering the data, any user?
No, Hadoop is basically not meant for that. Hadoop is basically meant for storing. I tell you like this. Say you have your traditional RDBMS where you stored your data. Last 6 months data you have stored. Okay. You go to any bank. Traditionally, I say like this. You ask them to provide your 4 years back statement. You think you'll be able to get instantaneously? Your 4 years back statement. You need to apply. You need to give a request saying that I want the statement of 4 years back. What they do is, probably from the archives, they are going to construct the database, and from that they generate the statement and give it to you. Because the bank will not be able to maintain last 20 years, 30 years, 40 years your transactions. The transactional data will not be maintained, right? Now, when your database fails to handle the data beyond some limit, usually what you do is you are going to archive that and keep it in the library. This is the library. Maybe you take the backup on the tape drives or whatever is whatever your organization is going to lay out, and being kept in the library. Anytime you want, from those archives you are going to construct your database, and you work again, you archive it. But if you see, the data which you have archived is not available to you live. Instead of you archiving your data and preserve it somewhere in your library, the same can be leveraged to your HDFS now, where your data is made available live. I hope you are following with me what I'm trying to share with you here, Loknath.
Yes, I do understand that. That's what the data warehouse concepts are introduced. And we have a database where we, like Microsoft BI, SAP BI, and all business intelligence tools is available. So how different is if we compare with big data?
That's where I say, all your traditional warehouses has got their limitation. Again, that is what I'm saying. All your traditional warehouses has got the limitation in terms of holding the data, right? Now, that's what I say. Can your traditional warehouse able to hold 2 petabytes data?
No.
Then what you do at that stage?
Okay. Hope I understand. Thank you.
So this data you're going to offload it to your HDFS, And time to time, what you are going to do is, you are going to run your MapReduce job. All your data, you offload it here. Time to time, you run your MapReduce job or pig script or a Hive query. What you do is, you are going to, from this available data, you extract whatever you need for that particular context and push this into your, and here onwards, your BI runs as usual. This already is there. You are not creating this one now. Please understand this one. This already in existence. This is your existing. What is the problem with this one? What is the problem with this one? Beyond some limit, you are not able to hold the data. That all you offload it to your HDFS and preserve it here, make it available, accessible. Time to time, you run your MapReduce jobs. You get what you need. That you put it here and run your BI as is and offload it here and bring what is necessary and offload it here, bring necessary. And this works as a cycle. And in order to make all these things possible, you are going to take your workflows using your Uzi, where periodically you run and make your warehouse to be filled with the required data so that it can be analyzed. So this makes you to understand your existing ETL or your existing enterprise data warehouse. Below this existing enterprise data warehouse, your Hadoop based data warehouse forms a layer. So this is going to be as is. Your Hadoop based data warehouse forms a layer beneath your existing data warehouse so that your things can be leveraged. I hope now you got the understanding. This, I think, somewhere during my discussion, I've clearly mentioned somewhere during the discussion.
What is the difference between the like HDFS and RDBMS? RDBMS, as I know, like this is relational database management system. And what is that? What is the difference? What is the advantage we have in the HDFS?
So when it comes to your HDFS, the biggest advantage, what I can say is the linear scalable. Linear scalable. Unlike your traditional RDBMS, it is not linear scalable. You want another 10 TB storage, you cannot just add it to your existing and make it you want to make that possible. Not possible with your traditional warehouses or traditional RDBMS. That is possible only with your distributed file system. I think from somewhere we have the noise. Yeah, Loknath. I think you are able to understand now. So this being a distributed file system spread across multiple nodes. Anytime you want more storage, you need not crash your existing environment. You can make it to, say you have a 50 node cluster now. You want another 20 TB storage, add another 4 nodes to the existing cluster. It's quite possible. And you want more storage, you can keep adding. Like that, today with Yahoo, we have a 13,000 node live cluster running. But that is not possible with your traditional RDBMS. Of course, in the coming days, you are going to see even your RDBMSs will be having this kind of infrastructure in the beneath layers, but there is always a bottleneck when it comes to the processing. Storage can be somehow leveraged. The similar kind of technique even can be applied to your existing traditional databases. But when it comes to the processing, it's going to undergo the pain. You got the point, Loknath?
Yeah. Okay.
Not only your storage, it is also fault tolerant. Fault tolerant, I mean, when you are working with thousands of nodes, one node becoming down is quite natural. Even if one node becomes down, still the data is being made available. That's what the beauty part of your HDFS. Hope you got some clarity now. Loknath, are you able to get the point? That's wonderful. That's really cool. Wonderful, friends. I really appreciate your weekend time to be with us, part of this demonstration. Hope you enjoyed the discussion. I really appreciate your patience for being with us for almost 2 hours. Hope you might have got the essential, the core ingredients with what our discussion has started. What is big data? What is Hadoop? Hadoop ecosystem, and how these components can be practically applied to your implementation, right? And as part of the course, has been mentioned by me, we are going to see all these what been discussed as part of this ecosystem. Apart from this, we also will be seeing the overview on Spark and Scala kind of thing, because when you go to the interviews, the interviewer may be very keen to know whether you are aware. They may not be expecting you to be good at Spark and Scala, but at least they may be expecting you to know a bit of Spark and Scala. So keeping that thing in the mind, a overview on Spark and Scala is also been planned as part of our program. And the interesting thing what I shared with you, you'll be getting exposure towards the real environment, so that you will not be feeling different when you go to the workplace. Anyhow, the environment is being set up on your laptop to get your regular practice go on. As part of the sessions, when you see the real environment, you yourself will understand, oh, my learning environment and my real environment are no different. They are one and the same. To give you that confidence, it is all the confidence, friends. I hope you understand the only difference between a very thin layer you are this side, you are out of the role, and when you are able to chase this and go this side, you are in. This is out and this is in. And here is the interviewer who works as a gatekeeper, either allow you to go in or remain outside. So in order to convince the interviewer, it is not that you come from a rich background, you convince the interviewer. No. The interviewer always looks at your confidence level. Even out of 10 questions, you answer only 3, but still there is a chance that the interviewer is going to consider you, because looking at your confidence. Because in IT, you know very well, what you are working on today may not be the same tomorrow, down the line 10 years. Every day is a new challenge to you. How quick you are able to adopt to the new things. And for that sake, your foundation, your fundamentals need to be very strong. When your fundamentals are very strong, you can achieve anything as part. So that is all our effort in making your foundation strong, so that you can flourish in the big data space in the coming days without any bottlenecks. Hope you enjoyed our demo today. If you have any questions, please feel free to ask, friends. Otherwise, we end up at this level. Once again, thank you for all. I thank all of you to be a part of this demonstration, extending your time. You have any questions, please? Yes.